Well, this is Old Electronics Fan, and this is part 2. We're going to pick up where we left off in part 1 and check out the 6C4 tube and do other diagnostics, try to find out why this thing is not behaving. If I recall correctly, this doesn't like... I don't think the meter in this thing likes being stood up on end, so I can't really do that. So, let's see, C4 6.3 volts, good. I'll turn that on. Maybe I can move this up a little bit. Alright. So we'll take this tube out of here and get this all set up, and then we'll test it. So I want, so filament X is this, and it should be on 3. Release that. And the plate is supposed to be 18. And it's supposed to be 2 on here. 1, 2. And then MS, so I do M. Oh, I have to adjust this. So this is the AC adjustment, and for some reason today I've got 125 volts. This is usually not set up this high, but so alright, I guess that's close enough. Now, so stick that there, give it a minute to warm up. That's a normal. On this, there's a normal, and then you've got all these letters for filament circuits that are not normal. But this one doesn't say I need to go set it there. But if you forget about this and it's set somewhere other than normal it's supposed to be, that will mess you up. So, alright, 3, 18, 2, 3, just double checking myself, 2 and MS, I've got M. So let's check, so I've got to check to see if this is shorted in any way. Alright, so now I do S. Well, the tube is testing good. And I know that's not necessarily a guarantee, but most of the time that is. So that's okay, surprising. So now what? I don't have another, I'm pretty sure I don't have another 6C4 that I can substitute in, which is my preferred method if I have that for an option. So, put this out of the way for the moment. Well, that's interesting. Okay. Let me just zoom back. Oh, I should go down too. Well, that's interesting. So what else can I look for that might be an issue? Oh, well, let me just for fun. They don't mention this, but so that is unplugged from there. Yes. Yeah, I don't think this is going to matter one way or the other. I'm going to shoot it anyway, but I don't think that's an issue. Let me check this, if I can. Yes, I should be able to. Oh, actually, I know this works because I was able to adjust it if that shorted. Oh, okay. Let me go back to my troubleshooting chart here. Well, according to the tube tester, that tube is fine. So what else do I have? Defective test lead. Ah, man. How would I know? Let's see. Alright, here's what I'm going to do. I know this is not... I'm pretty sure this is not the right cord for this. Let's just check the length. It's a little bit shorter, but okay. Now, alright. So anyway, so one of the possibilities is defective test lead or bad contact. I've checked that. I don't think that's an issue. Okay. The test selector in short. I'm running out of things to check. Alright, so and this doesn't tell me what it is, so I don't know what type of cable this is. It is shielded, so let's see. Alright, so turn you on. Turn this on. What is on? So now oh, that's interesting. Well, let me just let's see. It's working with this cable. Alright, let's try the other one. I went through all the trouble of buying and making this. Oh, wait a minute, now it's working. Oy, oy, oy. Well, okay. Interesting. Dirty tube socket, perhaps? It sure seems like it. Alright, so let's see. Let's go back to... I don't need this stuff anymore, do I? No. Let's go back to this setup. Oh, actually, if this is working now, then I want to go and... Okay. Set the test selector to open. Okay. Alright, now, let's see. Actually, let's go back to the... I want to go back to what they tell you to do when you're just about to use it. Alright, well, I found the right page. I thought I was looking for page 3, but it's actually page 4. And I don't think I printed page 3 for some reason. I still don't see it. I have the PDF so I can get it if I need it, but preliminary balance control clockwise. Okay, so that's where that is. Alright. So this is the initial setup, and set the test selector to short. Okay. And short the clips. Okay. And then, well, that tells me something, that maybe this cable is okay. So then set the line adjuster, okay, without overlapping. Well, I think that's correct. That's going to be a shock if I actually adjusted that coil to the right spot by accident. It's kind of looking that way, but anyway, we're going to go back to the maintenance to make sure that that's like it should be. So, without overlapping, close bars, separate the test clips. Yes, alright. Now, what I want to do though is I want to go back to the maintenance section, so I want to make sure that this is working properly. And so this is set where it should be. Alright, I want to go back here and so I think that's correct. So I go back here and I go here, and that looks like it might be overlapping slightly. So let's see, straighten these out. Because I played with that adjustment, I want to make sure until the gap is just closed. So, did I put that back in here? Yes, I did. Alright, so the question is, oh. Alright, now. Oh, this is working. That was very close. Interesting how that's... Why are you shorting? No. That off a minute. Interesting. So, I think you're supposed to wait a while for this to... Interesting how that's working. I don't know if you can see it very well. Well, even though do I have another one of these that would work better? Maybe? I don't know. Because I don't know if it's the fact that I get my finger too close to that pin. Alright. Come on. The other one worked better, I think, but come on. There it is. Alright. Now, that's interesting. Why are you doing that? It's very touchy, I know that. Okay. Is that picking up noise from somewhere? shouldn't be. I'm moving my lamp away from, the cord that powers my lamp away from this to make sure there's nothing that's messing with it. Okay, so now interesting. What I did was I moved the cord from this, was across this. And I don't know if that was causing the problem or not, but I moved it out of the way and this seems to be behaving better. I don't know. So anyway, let's go back. And you can't really see, the camera is not showing you what I'm seeing. So, alright, so now, that's just closing right about there. And it's definitely behaving a lot better now that I did that. So, I'm assuming that was my culprit. Now, they tell me at this voltage, if I'm looking at this chart right, 123 volts, quarter turn clockwise. Alright. One quarter turn clockwise, like that. And there it is. Okay. So, well, that was interesting. Now, set this, okay. Short the test clips. And they do. Okay. So if I short the test clips, that's supposed to open wide, and it does. Okay. Replace the case. Okay. So what we're going to do is that. Interesting. Alright. Do I? Well, actually, maybe I didn't need to do that. But alright, so for now, what I'm going to do is alright. Throw that away. Alright. So now I'm going to put this back in its case. I'm not going to screw it back together just because Murphy's Law and all that. But this should be fine. Well, yeah, maybe I should do what they tell me to do. So I'll put a screw in it. That way everything's, the case is grounded to the chassis of this. And well, there's only 2 screws, so it's not a big deal if I put both of them in. But let's just, for the fun of it, let's put that in. That should be grounded. Now, okay, next. So I've never ever used one of these. I've never seen one of these until I got my hands on this. Now, here's one of the things that gets interesting. And this is the part I definitely have not learned. They have this chart. Dissipation factor, power factor. And you use this chart on capacitors that are in circuit, if I understand this correctly. So, now, actually let's plug this in down here. And turn this on. And now if I want to, there it goes. Alright, so let's go back to 10.4. All right. So now we're going to go to preliminary. So this is open. So 5-minute warming up period, set to short. Okay. Then we're back to and short the test clips. Yes, that would do it. Oh, it's not working again. Why? It's just working. I got a flaky connection somewhere. Nope, I have something else going on. Oh, that's not nice. That's where it should be. What? Oh, it's a problem with the switch. Okay. Look what I said about Murphy. Anyway. Interesting. So let's find out what's going on. Well, all this trouble for a flaky switch, it would seem. Alright, what's going on here? If I push on this, why would that... Huh. Well, let's take the knob off. And somewhere oh wow, I really tightened that apparently. Why? Man. Okay. It seems to be tight enough. Let's see. I saw everything move, which is not ideal. Let's see. Yeah, it did move, I think. No, it's close. Alright, so I just tightened that a little bit. Let's see. And I'm going to go back here. I feel safer with that anyway. And that is on. Now, okay, let's see. So if I do this, yeah. Now I think that's what I want to do for line adjust. Okay, so I do this. Okay, open that up, Now if I go to open, and that closes like it's supposed to. Yep, that's working. Well now, I say, well, there and all I did was tighten that a little bit. Interesting. Okay, let me let's just slide the case back on. Let's start with that. On. Go. No. There. So, let's see. I behave now that I put the case on. Open. Go here. Okay. So let's see what happens if I put a screw in. Let's get crazy. Now we're really going nuts. Now I suppose it's possible that the screw is contacting something it shouldn't, but I don't think there's anything near it. I didn't look though. Well, if this putting the screw in messes things up, then I'll be checking to see what's happening. Now, okay, so that's all good. Okay, well now, so, interesting. Just, you saw how much I tightened that. It wasn't much. Okay, let's see. Alright. Circuit preparation. And just put it short the cables out. It works. Yep, it does. Alright, now let's see. I have, now I've got this, and according to this, a good capacitor. Alright, I'm looking through here because I read this a while ago. Well, let's just see what this does. So I'm going to put this on capacity, which I'm not crazy about that. Oh. Well, this is supposed to be 04. Okay, that's infinite capacity. That's not very accurate, because this should be an 047, and I'm about 0.27. Interesting. Well, let's see. This one is okay. That says, so this should be 0.47, and this is saying that it is so this should be somewhere around in here. But this is 0.5, 0.6, 0.4, that's 1. If I get down here, and it opens up again. Well, if I get that center line as bright as it can possibly be, yeah, right about there. Yeah, and it is 0.47. So it is working. Okay. It doesn't look like this starts at 0.1, so the smaller capacitors it's not going to like apparently. So I have a 0.05. Let's try this one. This is my imp that I pulled out of a radio, and it is it's supposed to be 0.05. And that's pretty close. Yeah, 0.05. And I already know this is a good used capacitor. This thing is surprising. It actually behaves like it's brand new. So, this is working. So, and if you have it all the way down to this, the window's going to close. Interesting. What else do I have? Just for fun. Let's see, I'm just looking through here. Page 5. Short test, open test. A good capacitor. Alright, I'm looking through here because I read this a while ago. Well, let's just see what this does. So I'm going to put this on capacity, which I'm not crazy about that. Oh. Well, this is supposed to be 04. Okay, that's infinite. Capacity. That's not very accurate. Because this should be an 047. And I'm about 0.27. Interesting. Well, let's see. This one is okay. That says, so this should be 0.47, and this is saying that it is so this should be somewhere around in here. But this is 0.5, 0.6, 0.4, that's 1. If I get down here, and it opens up again, well, if I get that center line as bright as it can possibly be, yeah, right about there. Yeah, and it is 0.47. So it is working. Okay. It doesn't look like this starts at 0.1, so the smaller capacitors it's not going to like apparently. So I have a 0.05. Let's try this one. This is my imp that I pulled out of a radio, and it's supposed to be 0.05. And that's pretty close. Yeah, 0.05. And I already know this is a good used capacitor. This thing is surprising. It actually behaves like it's brand new. So, this is working. So, and if you have it all the way down to this, the window's going to close. Interesting. What else do I have? Just for fun. All right. Well, I decided I was going to look for other capacitors to play with, but I have this old radio. None of the capacitors have been changed. I don't think they are. They have been. This does not have a schematic, so I'm not going to be able to find out for sure how accurate this is, but I thought I would play with it. But before I do that, there are a few things I want to mention. And okay, when you first start this up, and in the manual they tell you to check this from time to time. If you want to short your controls together on the short position, and then actually you'd use this, grabbing the wrong control there, and then you can disconnect. No, that's not what I want to do. So you can see that this is opening up, and you bring it together just until they touch, until the gap closes. You don't want overlapping, and I think that's pretty close right there. All right. So now that's all set. They say do that once in a while. I think most people have fairly stable power, but it can change over time. So then, there's that. Now, unfortunately, I played around with my camera a little bit, and I can't find any setting that would allow you to see this when it's overlapping. So you'll just have to take my word for the fact that it's overlapping, I guess. Now, all right, so a couple of things I want to mention, and then we'll play around with this. I think I mentioned before that you could use this chart to check out dissipation and power factor. That is actually only true if the capacitor is out of circuit. So that's one thing I want to correct, because I didn't get that right. And the other thing I've done is, well, actually I haven't done all of them. Before we get there, I'm trying to rush ahead here apparently. Let's check out, okay. Yes, all right. Now, okay, indicator bars, this is when you're testing to see if it's shorted. And you also use this for, obviously you can use this to see if you're testing something, you can see if it's shorted, because this will tell you. So anyway, because that's one thing they mentioned. Maybe also be used as a continuity tester, which is interesting, but you could do that. All right, so if the impedance across the test clips is more than 1 ohm, only closed bars indicate impedance of less. Only closed bars indicate impedance less than 1 ohm. All right, so if you're checking a capacitor, and the bars are closed, it says that it will be because the impedance is less than 1 ohm. Let's see, 2000 microfarad capacitor has an impedance of 1.3 ohms at 60 cycles per second, which apparently this is what this is using. Partially open bars indicate an impedance between 1 ohm and 10 ohms. Note that a 200 microfarad capacitor has an impedance of 13 ohms at 60 cycles per second. A short or very low resistance across a good capacitor will also cause short indication. Check for this condition. Let's see, but now, and then that's for the short test. If you're doing the open test, if you're doing an open test on the capacitors, you cannot use additional leads, try to make your leads longer. You have to use just this. I think, yeah. So short test, you can add another jumper lead or whatever jumper leads to this to make it longer in the short test, but you can't do so in the open test. And let's see. Only open bars indicate an open capacitor or capacitance less than 15 picofarad. Partially open bars indicate capacitance below 25 peaks, but more than 15. Some types of tubular electrolytics may also show open due to a peculiarity of their construction, even though they're almost always not open. Well, I would question that, but anyway, that's what they say. And it's discussed further in 9. Let's see. In-circuit open test should not be given to capacitors shunted with a resistance less than 35 ohms, because a false indication will occur. And let's see. Oh, and then if you have capacitors in parallel, an open one may be disguised by the fact that there's one that's not open. So that's one thing. Another thing, resonant circuits. An open may give a false indication on capacitors in resonant circuits unless the resonant frequency of the circuit is much below the test frequency, approximately 22 MC. False indication is very likely in open testing capacitors in resonant circuits above 22 MC. Let's see. And then they come up all sorts of stuff. And then, let's see where we're at here. Page 2, I don't want you. Let's see. And they talk about measuring, setting these controls, and if you measure and you come up with a resistance in k ohms, you can then set this somewhere and set the RC balance that lines up with that. And when you're in circuit, this control and this control work together to get get a closed bar reading on here. Now, if you're out of circuit, when I was playing with this, I didn't have to worry about this. I put this on maximum, and I put this all the way to the right, and that always gave me an indication, a closed indication on here, telling me what the value was. Let's see. And capacity measurement, you can add clip leads to this and you'll be fine. So let's see. So they talk about starting with this, rotate it till you get the bars as close as they're going to get, then you adjust this to try to bring them in closer, then you adjust this so you go back and forth. Now, I've never played with this in circuit, period, ever. So I thought it might be interesting to do so with this. Now we've got this. I'm just going to quickly check to see if these, nope, nothing other than capacitances reading there. Let's see, what are you? I'm just quickly checking to see if there's any resistors across these that would give a false reading. Nope. Alright, I think I've measured all the others, so we're probably good here. Whoops, no, I want you. Go away. Alright, so now I've got these electrolytics I've already checked, and as expected there really wasn't, well, I checked first of all to see if they were, if they had too much voltage on them. Now, I haven't looked at the values on these. These could be higher in value than I want, but I doubt it on this old radio. So we're going to go to capacity. Oh. Alright, so I really wish you could see this. I don't know if I zoom in more, you're going to be able to see that better. And no. So what I'm going to do is, they want the line to be as bright as possible, and I'm right about there. So I'm on, let's see, well that's 15, that's 10, so we're guessing that this is maybe 11. Alright, so let's see if we can. Alright, well I'm going to go to this other capacitor, and alright, and unfortunately I can't get to it directly, so it was conveniently a nice little hole right there. So capacitor, okay, yeah, I'm just double checking, make sure I didn't screw up. Alright, so I'll go here. Well, I think that's 10. Let me see here. Somewhere in there, let's call it 9. Okay. That's what this is reading. So, I didn't look at this beforehand, I don't know what it is. Let's see if I can't, this has got a really short lead there, it doesn't want to twist. So let's see what we got here. 10 microfarad, okay. So this is saying that it is 9, 10 thereabouts, so that's pretty good. Let's go back to this one just for fun. And nobody's home? Really? I just had microfarads there. Well, let's go here. Alright, so this is where we get to learn how we were using this and this, by the way. These 3 controls are what you're going to use when you're doing in-circuit testing. So, the instructions tell you, I don't know if I read those, the instructions tell you that you use this to get it as close as you can, and that's kind of where I'm at right there. I'm actually reading off scale a little bit. And now I use this to try to bring it in. Now I've maxed this all the way counterclockwise. So I've got one more setting I can change. So I go from set 0.7 to infinite to the 0.6 to 10.5. And now you see that I've got this. And now well, this is 0.1. This is, I don't know what this is. So I'm just going to guess 50 nanofarad. So this went from reading around 10 microfarads, which was wrong anyway, because it's supposed to be 20, and now we're reading that. So given that I'm getting a reading, that should mean it's not reading shorted, and it is not. Yeah, if I read this correctly, closed bars. So, let's see, only closed bars from capacitor. Okay. Let's reread this. Only closed bars indicate open capacitor or capacitance less than 15 picofarad. Partially open bars indicate capacitance below 25 picofarads, but more than 15 pico. Yeah. So, but that shows you how you use these controls and those controls. And just to confirm that this is still a capacitor and it's not open, let's put this on here and there, and we're going to read this and see what it does. So I'm going to move this over here so you can see it, and my arm won't block you. Alright, so interesting. Keeps dancing around. Normally a good capacitor will charge and keep charging and charging. Let's see how this one behaves. Because this one was reading okay, so what do you tell me? Yeah. Yeah, so that's how it's supposed to work. So that capacitor is dead. So let's now we'll look at capacitors in there. This is a capacitor block, and this one has 1, 2, 3, 4, 5 capacitors in it. It looks like maybe 6. You think? Or is that just the ground? I guess that does look like 2, 4, 6, 7. Looks like they have 7 capacitors in that thing. Alright. Well, let's find a ground somewhere. This is grounded to the chassis, so we'll just do that. And let's go to, because like I said, I have no idea what the capacitor is, what value it is, and you want to weigh on me, so we go over here. Fine, be that way. Now, alright, so now, this is apparently what they were talking about before. I don't get a completely closed eye, so now I go here, and now I get it closed. And okay, well that's interesting. So I did have to use this. That's way down here, and there's calculations you can make using that. In fact, I think, oh, I had this up there. Well, let's just try that. Yeah, okay. So this is what they were talking about, I believe, in the manual. I have this on 0.7 to infinite. You notice I can't get this to close. But if I do this, and I do that, and then I bring this down. Now if I go too far with this, it opens up again. So try to get that line as bright as try to get that line as bright as possible. Try not to hit your control. And that looks pretty good. So this is saying 1.5, let's see, 1, 2, 3, 4, 5. So 1.6 microfarad, roughly. Maybe 1.7. Is that correct? And with older radios, they typically had capacitors in that value. I have no idea what this one might be. So let's go to another one, just for fun. Let's see what we got there. And that one, oh, let's go back. Let's go back here. Yeah, that's not. Let's go back here. No. So either that capacitor is open, except it's not showing open. It's not shorted. So if I short that, that will close. Or the value is below 0.5 or thereabouts microfarad. Because that's so. Yeah, that's not exciting, is it? Alright. So that part of that capacitor may or may not be any good. Let's go down here to, let's see, that goes up there. Alright, let's pick one of these. Let's go to one of those. Alright. And that one's also not doing anything. Fast A. doing this. Oh, wait a minute. Oh, there it is. I'm on infinity now. And that's 0.15 thereabouts. Okay, so that's reading anyway. And then I have this one, I think. And it's all the way down. There we go. Yeah, that's below 0.1. Interesting. So it seems to be working. It'd be nice. Well, I don't have a schematic for this, so I have no idea whether these values are anywhere near what this is reading. And of course, I could unsolder these and use some of my other modern tools and find out what that says. But I thought it'd be fun just to play around with this a little bit and see how it behaves in circuit. And so you find yourself using this, and this when you're testing capacitors in circuit. And this could be an indication. If you got this not giving you what you want, and this is infinite, then you come up here, and then you can get it somewhere where you want it. So this seems to be reading somewhere around 0.05. Yeah. Or less. Actually, it looks like it's slightly less. 0.01 or something like that is my guess. I'm just guessing. So, yeah, it's an interesting little unit. It's working fine. This is so bizarre that I had to tighten that up a little bit. Actually, I want to check. Okay, I'm just going to... I don't know what I'm going to do with this radio. It's not something that I'm entirely sure I want to keep, but unless... Alright, so I'm going to check this out and see. I don't think there should be any voltage on it, but let's find out. And let me see. We have essentially no voltage. So, alright, I'm going to use this. This is the one I go to most of the time. My meter will measure capacitance. My multi-measurement tool will measure capacitance. This is the one I tend to use most. Occasionally this one won't read a capacitor, but this one will. But that usually indicates that the capacitor is not entirely healthy. So anyway, let's go to, we know it's, according to the label, it says it's 20. And it did say 20, didn't it? It's got to be that much. It's big. Well, that explains a lot. So this is telling me that this is only out. Yeah, but it's 1 microfarad. Interesting. Just for the fun of it, I want to see how it reads on this meter, because I don't think I've used this for that yet. And we want, okay, nanofarad, alright. Do this, and this doesn't even read it. Whatever. So this is saying 381 nanofarad. Interesting. Oh, you can't see that. The glare. 372 nanofarad is what that says. Interesting. Well, let's just go one more tool. What the heck? Why not? This one does not care how you hook it up, as long as you have 2 leads on the capacitor. Come on. You're not supposed to do that. Stay. .4 microfarad. ESR 0.14K, so yeah, that's not healthy. I don't know if you can see this. 1.4 k ohms. Yeah, so it's not healthy. Right here. Oh, I gotta reread that because I want to check what I think I said and see if it's right. Come on. Those are handy until they're not. Oh, it's changed. Why? 945. So 100 nanofarad is 0.9. So it's almost 1 microfarad. Okay, so this one says it's almost 1. Let's see what this one tells me. Again, it seems to be changing its mind about what measurements to give me. 0.7? Whoa. 0.8. So, alright. That one's saying 0.9, this is saying 0.8, this was 0.3, something like that. Yeah. So anyway, so that the bottom line there is that this capacitor is toast. Yeah. I don't remember this humming horribly, but and that's where that belongs. Not that I think I'm going to be using it anytime soon. But if I stick that close to where it belongs, if I decide to use it, I can solder it back together and do something with it. This is interesting. So anyway, I'm wandering far afield, it would seem, as usual. So this was telling me it couldn't read this capacitor with good reason. The capacitor is not healthy. The ESR on it's insane. 0.14 k ohms is definitely not good. So I'm curious about something. I've got various resistors. We're going to do this, and I got one that's 2.2 ohms. I'm curious to see what this does with that. So I'm in short mode. We're going to check out a 2.2 ohm resistor. Yeah. So that tells you have resistance as opposed to no resistance. Oh, really? Okay. I just started up, so maybe it's just cold. I don't know. Yeah. So this doesn't do anything. This doesn't do anything. When you're on short or open, this doesn't do anything, which is what I expected it to do. Because this, when you're in either, actually I didn't look at the schematic, but I'm betting if it's in this mode or this mode, the part of the circuit that measures capacity is disconnected, which means that none of this is going to work. It's just whatever. Interesting. So, well, for some reason, my recording stopped. I have no idea why. So, I had this resistor as 2.2 ohms, and you notice that this didn't completely close, which makes sense. Anything below an ohm should read as a short. This is, what are you? Nope. Come on. Well, did I get the wrong one? 0.2 ohms. Apparently a fuse resistor. So that's definitely below. And we'll hook this up. And it shows short. 0.2 ohms. So anyway, this, it works. I think I'm gonna have to double check the calibration on this. This line, there shouldn't be, you can't see it on the camera. There's a small line showing in it. It should be touching, and it's not. So I don't know why that changed. I had it adjusted properly once, and it stopped. It's not. It's close enough that it probably doesn't matter, but I'd like to reset it to what it's supposed to be. At least I'm pretty sure that's what it's supposed to, how it's supposed to be. Let's double check. Maintenance. Yes. So the gap is just closed. And then turn it clockwise further depending on the voltage that this is receiving. So, yeah, so that line should be touching. It's very, very close. But it's not dead on. So, yeah. Anyway, so I'm going to wrap up here. This is a neat little unit. It's been superseded in a lot of ways by modern equipment. But if you're just quickly going through a radio, maybe you want to check things out before you turn it on. You can quickly go through, check and see if any of the capacitors read short. You might get an idea of what the value is. What were they saying? They said something about if you are reading it in circuit, one of the readings, which was, I can't remember now, it's in the manual, it might be slightly different than if it were out of circuit. But the use case for this would be to quickly check capacitors to see if you have anything that's not healthy, i.e. shorted, for instance, because you really don't want a shorted capacitor in your electronic device. You kind of want to avoid putting power to something that has a short in it. So maybe this could help you quickly find something like that. It's fast. I mean, it's either shorted or it isn't, as you saw. So, you know, it's an interesting thing. And as I mentioned, you can use this for continuity if you want to. It doesn't give you resistance per se, because as you saw, I had that 2.2, and well, you couldn't see it in the camera, darn, but there was a small gap between the two bars, and that told you that you were close to the 1 ohm, lower level. Because you get below 1 ohm, and then it does, then the two bars to touch. But so yeah, I'm kind of intrigued by this. I think I might have a use for it. It's something that I want to hang on to, so I'll have to see if I can find a use for it. I just think it's a neat little thing. This is old technology, of course. It has its limitations, but if you enjoy playing with vintage test equipment, this is kind of a neat little thing. So I'm going to wrap up at this point. Hopefully you learned something, and hopefully you enjoyed this. If you did, it'd be great to have you check that click the like button. Comments, again, are always welcome, even if you disagree with me. Hopefully I learned from the disagreements, and I get a little bit smarter along the way. And of course, subscribe if you like what you see, and then hit the subscribe button. and hopefully I'll see you next time.